of our lesson today is called the Wheel of Algebra. We're going to make a few adjustments here with the teacher's name that is listed. We're going to pretend like it says Miss Cheryl. So it says Miss Cheryl is trying to make algebra a little more exciting. So she's going to use a prize wheel. The spinner must always start from the position shown above, meaning this position right here where you see that blue arrow, that is the position where it starts, and it spins in the counterclockwise direction. In the little pictures up here at the top, let's put a little arrow to remind us what is counterclockwise. It is the opposite direction that the clock hands move, counterclockwise. And if you land on a line, you can pick which of the two sectors you land in. Otherwise, if you just land in the sector, that's the prize that you earn. We're going to begin by labeling the angle measure of each sector. So if we think about this starting position, where it was pictured up there, I'm going to use this purple ruler to represent this. And if we're moving in this counterclockwise direction, I first want to ask you, if I were to travel one full distance around my spinner and land in the exact same position, how many degrees have I traveled? Awesome. Okay. So if it's 360 degrees around the entire circle, how many degrees would it be for just half the circle? 180. What if I just go a fourth of my circle? 90. Okay. So let's take a moment here, and I would love for us to fill in our angle measures. Here's what that would look like. So the ones that we talked about together, we saw 90 degrees up here at the top. Halfway is 180. If I go all the way around the circle and I end back where I started, I'm going to label that as 360. Now, actually, something interesting about the starting position, let's say that I start here and the ruler has not moved at all, and so technically I'm also ending here, meaning I have not traveled. How many degrees technically do you think we would say? 0 degrees. So right next to this label of 360 degrees, I would like for us to also put a 0 degrees followed by a comma. So if we start and end in the same place and we haven't actually moved, we've gone 0 degrees. So using this, I would like for you to take a moment to fill in the rest of the angle positions. So for example, you're going to be filling in an angle here in this box. You're going to fill in an angle there. Every single time you see a line, that's an angle measure that I want you to fill in degrees. So I want you to think about how do you know what each label will be. So in double checking how we have this labeled, every single increment, each of the lines, was just adding 30 degrees from the previous angle measure. So we have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and that makes sense why we're landing at 360 at the end, and that's representing traveling one full distance around our circle. Now, I do want us to think about this as being an x and a y axis. That's the coordinate plane that we talked about at the very start. So off to this side here, let's put in a label. So think of this as our x-axis, and then up here, this is our y-axis. And we have some different names for the different areas, the different regions that the angles that we have labeled are falling in. So this very first region, so from 0 to 90 degrees, those angles, we say that they are in quadrant 1, and we use Roman numerals to represent our quadrants. So I'll do a little Q to represent that. Quadrant, think about quad, it's representing the number 4, so it's like dividing our coordinate plane into fourths. When we take a look at the next one, so still thinking about going counterclockwise, the angles in between 90 and 180 degrees, those are in quadrant 2. Angles from 180 to 270 are in quadrant 3. And angles between 270 and 360 are in quadrant 4. So we're going to label this. We're going to draw this on what looks like the X and Y axis here on our paper. So what we're going to do is we're going to draw a line here to represent our starting position. And then we're just going to sort of do our best to estimate where that 150 degrees would be. It's over here in the second quadrant. And then I'm also going to put one more line here that's showing the direction of our rotation, so showing that we're going counterclockwise. I'm going to label this position over here to the left as 150 degrees. And a couple other pieces of our picture that we can label. The starting position, this is actually called our initial side. And then the other line that we drew to represent our ending position, this is called our terminal side. And generally, this is an example of an angle that has been drawn in standard position. So standard position is always when the initial side is on the positive x-axis. All right, let's take a look here at number 2. It says that Tara actually spun 510 degrees. Did she win lunch with Ms. Sharrow? And we're going to sketch the angle again on the axes. So anything above 360 degrees just indicates that the spinner is going around more than once. So if she spins 510, she's gone one full time around to get to 360. If that spinner is still moving, this next position would be 390. This position would be 420. This position would be 450. We're still adding 30 degrees each time. So take a moment here on your own, and I want you to decide where is the 510 degrees, and did she actually win the prize that she wanted? All right, so if we do keep counting around our circle, continually adding 30 degrees, it looks like, yes, she got the prize that she wanted. She just went around the spinner more than once. So that 510 degrees actually has the same terminal side as the 150 degrees. And so the way that we can sketch that picture here is we're still going to show our initial side in the same place. The terminal side is still going to be in the same place. That's representing the Lunch with Ms. Sharrow prize. And the way that we're going to show that we've gone around more than once is starting with our pencil here on the initial side. We're going to go one full time around our circle, but then we're going to keep going all the way until we get back over to that same ending point. So it kind of reminds me of like a spiral, sort of like a cinnamon roll shape in the middle when we are going around more than once. So we saw that there's two different ways that we can label that terminal side position. So we saw that it's 510 degrees or the original label of 150 degrees. There is something special, there's a special relationship about angles that share the same terminal side, and I'd like for us to write down here that these are called coterminal angles. If you are co-parenting, you are sharing the parenting responsibilities. If angles are coterminal, they are sharing the same terminal side. The only difference is, well, how many times did I have to go around the circle to get to that side? If I were to think about going around and around and around, how many different coterminal angles do you think there are for this position? An infinite amount, that's right. You could go on and on forever. We wouldn't, but you could. So it's not just that there's only two of them. We could go on and on and on listing them out. Now, I want us to think about, okay, so how could we generally find the measure of a coterminal angle? So I'm going to bring my purple ruler back over here. I'm going to put it on the terminal side. I want you to think about this being the measure of 150. Now I want you to watch how far the ruler is traveling to get back to the same position. So if I start at 150, and then I'm spinning around, and I'm going to land in the same place, how many degrees did I go? I'll show you again. How many degrees if we go one full time around the circle? That's right, it's still 360 degrees. So that's the thing. It actually doesn't matter where we start. Anytime you just make one full trip around, it's 360 degrees that you're traveling. So anytime you're wanting to get a coterminal angle, you're going to take your beginning angle, and you're either going to add or subtract 360 degrees, and that's going to give you a coterminal angle. Now, if we were to check our work for this off to the side, starting with 150, sure enough, if we add 360, that is equal to 510. Now it also goes the other direction. Let's say that we started with 510 and we wanted a coterminal angle that was smaller. We would just subtract 360, and that's going to get us down to 150. So adding or subtracting 360 always will give us a coterminal angle, an angle that the label would be in the same position because they share a terminal side. Question 3. It says if we land on the starred line, we get an extra spin. So the starred line was really the x-axis. So if you look on your spinner, we have some stars there on either end. And it says that Jacoby spun 170 degrees. We're going to see how many degrees he was away from getting an extra spin. Well, if we know, starting here at our initial side, getting all the way to the star position, halfway around our circle is 180 degrees. 170 is just a little bit less than that. So let's draw a terminal side here to represent the position of 170. How many degrees short was he? 10 degrees short. Degrees away from getting an extra spin. Let's also actually label the 10. I'd like for you to label the 10 degrees right here in our picture. All right, next we have Allie. Allie was 70 degrees away from getting an extra spin. We're going to see how many degrees he could have spun, and we're going to see if we can give more than one possibility. So again, we know our starred line is like our x-axis. If we're 70 degrees away from getting an extra spin, one possibility, if the terminal side is in the second quadrant, could look something like this, where the 70 degrees away from the extra spin, I made that a much bigger section here on my picture. How many degrees would we have to go from our starting position to land on this line? 110. So if 180 degrees is how far we need to go to get that extra spin, and we subtract 70 or we subtract 110, it'll work either way. We're going to get what the other measure is. Now, it makes sense here that 110 plus 70 is equal to 180 because that's the entire distance for that first top half of the circle. Now, there's other possibilities. So one possibility is 110. I'm actually going to label that up here in that second quadrant. If he was only 70 degrees away from an extra spin, maybe he spun a little bit too far. So maybe the terminal side is down here in the second quadrant. That's another possibility, that he could be 70 degrees away. Now, if we think about the label down here, this would be like starting at 180, and then we're going to add 70 to that to get down here below this is going to be an angle measure of 250. So it could have been that he spun 110. It could have been that he spun 250. It could also have happened over here in the third quadrant. That's another way that it could have been 70 away from an extra spin, because it could have been getting to the x-axis on the other side. This is going to be a measure of 290. He also could have spun it to land somewhere in the first quadrant. So we could have been 70 degrees away here, and that angle would just simply be 70 degrees. So here we have 4 different possibilities listed for being 70 degrees away from getting that extra spin. So I want to give a name here to this distance that we have been measuring in the previous 2 problems with both Jacoby and Ali, how many degrees they are away from getting the extra spin. That is something special called a reference angle. And all we need to know about a reference angle is this is the distance from the x-axis. So the x-axis here is what was representing the extra spin. When you only measure the distance to the x-axis, it's a reference angle. We're going to take a look here now at number 4. So now we have a student named Reed. Reed broke the rules, and he spun clockwise instead. He spun 35 degrees clockwise from the starting position. Let's see if we can draw and label Reed's spin. So when he went clockwise, so let's think about the way that a clock moves. So clockwise is going to be this other direction of rotation, and so that's the direction he's moving, and he just went 35 degrees from the starting position, so it's not actually too far. It's going to land us down here in the 4th quadrant, and I'm going to show a little arrow here to show that he went clockwise. So here's what I want you to know about the direction of your rotation. If you're going backwards, if we're going clockwise, this is actually going to give us a negative angle measure. We need something to specify that this 35 degrees, it's not up in the first quadrant, it's down below because we went the opposite direction. So let's go ahead, and I'd love for you to put a big negative sign here. Negative angles are what results when we go in the clockwise direction. So this is Reed's spin. Now it says that Nick followed the rules, meaning Nick went counterclockwise and landed in the same spot as Reed. We're going to find the smallest number of degrees that Nick could have spun. So Nick's spin would look like this, still starting here, but we're going in the positive direction. We're going counterclockwise, and we're landing here in the same place. So Nick's spin is just going to have a different arrow, but notice how we're still sharing the same terminal side. How could we figure out the number of degrees that Nick went and he landed in the same spot? What would we do, Christopher? Yeah, so we know one full time around is going to be 360. We know that we're stopping 35 degrees short of that. So it looks like Nick's spin is positive 325 degrees. So that's going to be another way that we can label the same position. Just maybe put a box around this to separate it. Notice how positive 325 and negative 35, those are coterminal angles. Sometimes coterminal goes into the negatives, and that's okay. If you think about starting at 325 and subtract 360, we're going to get to negative 35. So I just want to make a note here that here we have another example of coterminal angles, and the direction that we are traveling from the starting position is what defines if we have a positive or negative angle. So the other note I'm going to make here is that the clockwise direction, that's what results in negative degrees. And if you want to put a little picture off to the side here of clockwise, so clockwise goes this direction. Whereas how we started today, counterclockwise is what gets us our positive degrees. And if you want to make a little picture here of how counterclockwise goes, it would look something like this. All right, let's take a look here at question 5. So it says when Samra went, the spinner point landed 2 centimeters right and 3 centimeters up from the center of the spinner. We're going to find what angle did Samra spin. The hint here is to draw a triangle on the axis. So if this is the center of our spinner, and her spinner point was 2 centimeters to the right and 3 centimeters up, here is a picture that kind of is reminding us of the shape of a right triangle that we can help use to represent the position of where her spinner landed. And we want to know what angle did she spin. So I'm going to put angle theta symbol in that angle there. And we can actually solve this based on what we did yesterday. We have 2 of the side lengths of our right triangle labeled. And so we just need to do an inverse trig function to solve for the missing angle. Now, based on where theta is positioned, the 3 centimeters is the opposite side, 2 centimeters is the adjacent side. So this is making me think about tan. Tan is the ratio of the opposite side over the adjacent side. So the tan of our angle here is equal to 3 over 2. To solve for the angle, we need to do the inverse tan of both sides. So that's going to cause the tan to be undone or canceled out from the left. And we can go to our calculator here for the last step. I'm going to press second tan, 3 divided by 2, and we see that angle measure, it's about 56.3 degrees. All right, so we see that we're going around our circle more than once, and so what we could think about is take this label of the 640 degrees that they gave us. If we were to subtract 360, we're going to get a co-terminal angle. So this terminal side could also be labeled as 280. And so now that we know it's 280, this very bottom label here is 270. And so we know that we still have a distance to go. So it's just what we have here highlighted in yellow. This is our reference angle, and that's going to be 80 degrees. So it's just 10 degrees in. If we think about that as a 90-degree section, we have 10 degrees already traveled from 270 to 280, so then we would have 80 degrees more to go. So that's what the reference angle is. All right. So we do just have a couple minutes left. Here's what I'll say. So this will be posted on Schoology. I would love for you to try question 2 and question 3 to finish out the check for understanding. There will be an answer key posted there for you to check your work, as well as your quick notes box here of just filling all the pieces all into one place.